Okay, this is part 2 of Unit 5A, and we're just looking at our statistics, beginning of statistics here, and we're talking about how to find samples and what are some common sampling methods we use when we're doing studies in statistics. In the last video, we talked about simple random and systematic. Now we're going to continue here with what's called convenience sampling. And this, the nature of the sampling is built in. We choose a sample that is most convenient to us, such as people who happen to be in the same classroom, or proximity is one. Maybe your closest friends or something like that. I love this little example here. This lady sees some guy out walking his dog and says, "Hey, do you support the death penalty?" He's conveniently closest, and she's gathering data, so she is getting data from the population. But again, it's just convenient. There's no really randomization to it. It's just whoever is closest, or whatever's the most simple to do. So that is convenient sample, and we just use, again, the most readily available results that we can around us. The last is what we call stratified sampling, and we use this method when we're looking at or are concerned about differences amongst little subgroups, which are called strata, within the population. And so we'll first identify the subgroups, and then we're going to draw simple random samples within each of those subgroups. And the total sample consists of all the samples from each individual subgroup. So one simple example is, if we're looking in the population of, say, everyone on Earth, and we break it down into females and males. Okay, that is in 2 different strata, and then from there we would get a simple random sample of females and of the males, and then compare the 2 groups. So that is a stratified sampling. So let's look at this question right here. In regards to a good representative sample. Again, each of the samples we talked about as far as collecting up above has good and bad, and some are more simple, some are more difficult. But the one big thing you're looking at is, do you have a good representative sample of your population? Because if you don't, then your study could be very inconclusive or very biased, or tell a bad story or tell a good story. It just depends on how your sample looks is a big portion of that. So we want to determine the typical dietary habits of students at a particular college, and we'll determine whether each of the following samples is likely to be representative, and then explain why or why not. So our population here is whatever college this is, and our first sample is students in a single sorority. Okay, is this representative of the entire college? Not so much, because not every student is in a sorority. So we're instantly cutting out all the people who are not in a sorority, so we could have some bias here, where we get a particular group of people and we leave out others. So sample 1 is not going to be a good example, because not everyone, again, participates in a sorority. Sample number 2, students majoring in public health. Again, just like the first one, not everyone majors in public health. And so if we only look at people in public health, then we're only looking at a small group of students at the college. Okay, sample 3, students who participate in intercollegiate sports. Same argument as before. We're only looking at a small portion, because not everyone participates there. Sample 4, students enrolled in a required history class, and there's our key word there, required. So this is going to be the best of the 4 samples that we have. This is going to be the best representative sample, because if the course is required, that means every student at some point is required to take this history class, and so we're going to get the best kind of mix of students in there. We're not looking at a particular group. If everyone's required to take that history class, then we have the potential of reaching every different kind of student in the school. So that would be the best of the 4 samples. Okay, next, in these 3 questions I got here is let's identify the sampling method. Again, and we're looking at those 4 we mentioned earlier: simple random sample, a systematic sample, convenient sample, or a stratified sample. So the first one, an IRS, which is the Internal Revenue Service, auditor randomly selects for audits 100 single taxpayers in each of the filing tax brackets. Okay, so he's focusing in on a subgroup of all the taxpayers, and that's the single. So again, when we focus in on subgroups, then this is what we called stratified. Because then he's going to be looking at those subgroups in all of the filing tax brackets. So it would be a stratified sample. The next, U.S. Weekly Magazine predicts Grammy Award winners by polling readers who voluntarily respond by email. Okay, people, so they send it out to their subscribers, and then they're looking at people who voluntarily respond. That is a very convenient way to get a sample, so we would call that convenience. Okay, they've already got all the people's names on file. They send out a quick email. People who voluntarily respond, that's how they gather the data, so that is a convenience sample. Okay, number 32 here. Every 100th cast iron pipe that comes off an assembly line is tested for strength. Okay, so every time we count it down, 99, 100, and we grab that pipe, they test it for strength. And the next 100, they grab it, they test it for strength. That is a very, what we call, systematic process. And so that would be systematic sampling. Okay, and that's a look at identifying, based off of the information given, what type of sampling method is being used. Okay, now there are 2 basic types of a statistical study when you're trying to gather information about a population. Okay, one is an observational study. In an observational study, the researchers just observe or measure certain characteristics of the sample, but they do not attempt to influence or modify those characteristics. So they don't intervene in any way, they're just observing, as it implies there. And then next, in the second one, we have in an experiment, researchers they apply a treatment to some or all of the sample members and then observe what effects, what are the effects of that treatment. So again, we have an observation versus an experiment. An experiment, we intervene. Observation, we're kind of hands off, we're just watching, and we don't try and influence or modify. Okay, when we're looking at what's called a treatment and control groups in an experiment, so this is looking at an experiment. Okay, a treatment group is a group of samples who receive some kind of treatment as they're being tested. And then the control group is the group of sample members who do not receive that treatment. So again, we have our treatment and our control. If you ever watched shows such as Mythbusters, one I really like, they always talk about their control. And that's where they haven't done anything on their experiment. They're just testing without applying any kind of intervention. As they use it as a control, as a baseline. Now, it is important for the treatment control groups to be selected randomly and to be alike. You don't want to stack the deck when you're doing those in experiments. Also in experiments, we have what's called a placebo. And placebos, they lack the active ingredients of the treatment being tested on the study, but it looks and feels enough like the treatment, so the participants can't distinguish whether they're getting the placebo or the treatment. So, for example, if you're studying the effects of a new medication, someone may get one pill that is the actual medication. Someone else may get the same, it looks like the same pill. In a lot of cases, it's just a sugar pill. And but again, that sugar pill would be called a placebo because it lacks that active ingredient. Now, the placebo effect refers to the situation in which the patient improves simply because they believe they are being or receiving a useful treatment. So even though they may be just getting a sugar pill, they feel that they they don't know whether they're getting the sugar pill or not. And that placebo effect is what we see happening when people receive a treatment that they feel like is going to improve. Okay, now when we're doing experiments, we have blinding. So you have one idea is what's called single blinding. It's basically where the participants don't know whether or not they're in the treatment group or in the control group, but the experimenters do know that. An experiment that is double-blinded is where neither the participants nor the experimenters, the people who are administering the treatment, know who belongs to the treatment group and the control group. You try to eliminate as much bias as you possibly can when you're doing blinding experiments. Okay, now when we go back to so all that was on experimental studies. When we look at observational studies, we have a retrospective study, or another name of that is a case control study. That is an observational study that uses data from the past. So you're looking at past data such as official records, interviews, and looking at that, the sample naturally divides itself into cases who are engaged in the behavior under the study and groups of controls who did not. So again, we have cases and controls here, and this is looking on previous data. So let's look at an example of that one, because that one's a little bit harder to explain. So we're going to determine whether or not the following is an observational and experiment. If it's an experiment, we want to identify the control treatment groups and discuss whether single or double-blinded is necessary. If it's observational, we want to state whether it's a retrospective study, and if so, identify the cases and control. So we've got a study at the University of Southern California, separated 108 volunteers into groups based on psychological tests designed to determine how often they lied or cheated. Those with the tendency to lie had different brain structures than those who did not lie. Okay, so as we look at this one, this is looking at previous data. So this is, they're just observing, they're not intervening at all. So this is observational, and it is retrospective. Okay, and again, retrospective, because we're looking at data from the past, and it's going to naturally divide us into people who said they often lied and cheated versus those who did not. So it's retrospective, and when we look at this one, we would say that the cases are basically our volunteers, our individuals who had tendency to lie. So we'll say those with tendency to lie. And then our control is going to be the other people. So we're going to say those without the tendency to lie. And that's how we break it into, so that should say lie. That's how we break it into our different cases versus controls. So we'll look at 38 and one more example to end this in the next video.